Hopefully the stream has begun. As always, I've got to take a moment to make sure that everything is working. Because I don't want to be talking here for an hour and only to find out that the audio is not working. Okay, good. Looks like we have audio. All right, welcome to what I believe to be the 11th episode. Maybe it's the 12th. Let's go find out. So if you go to TylerMakes.com, which you should check out if you haven't, you can see what I make. I have little videos on stuff that I'm working on, and I have links here to YouTube as well as Twitch, and my Twitter, so you can find out what's happening. But anyway, this is how you can, if you need to, this is probably the easiest way to get back to my videos. Oh, look at this. We're on part 12. So with part 11, we left off with working on A-starred algorithms for pathfinding for our little players and enemies. Well, actually, I guess it's just players right now. So here's our player, and it finds a path around the map, and that's all awesome. And we have it labeled as A-star, and that is not actually what it is. This is actually just kind of simplistic pathfinding. This episode, we're going to make it a little more robust, as well as hopefully get to making it an actual A-star algorithm. So what we have currently is this, and again, we're following the tutorials on A-star on Introduction to A-star from Red Blob Games, which is a fantastic site where this person writes all about game development and some of the actual algorithms that go into game development. So there's some pretty cool stuff. I recommend you check it out. Anyway, we are going to continue with our implementation. So what we've got is we've currently got our pathing to a given location. And then we have early exit, I believe, so that we're not wasting time looking at places we're not going to go. But what we don't have is movement costs. And then I think this is Dijkstra. I think that's how you pronounce it. Dijkstra's algorithm, which does a little difference to breadth first search. So it does cost of movement. So that when you move, it's dependent on, how much it costs to move through different terrain. And then beyond that, Dijkstra's algorithm can then be extended with here's breadth first, and then greedy breadth first. So if you look at this, this greedy breadth first tries to not waste as much time looking at spaces that are not likely to get it to its goal. And then if you continue adding to the greedy best first search, you'll eventually get to the idea of A-star algorithm, which I think combines basically Dijkstra's algorithm and greedy best first to get an efficient and kind of nicer path. And that's what we eventually want to get. So here's a cool thing where you can see the spaces that are checked and the path that is found in these different algorithms. In some cases, one performs better than another. But it's basically generally viewed as A-star is kind of like the gold standard. If you ever look into pathfinding, you will hear about A-star. So that's our goal. So we want to get there. So let's get back to where we left off. Again, if you have forgotten or don't already know, if you go to github.com/TylerMakes, you can find my repo. And there's just one called Bulbasaur, which is this project that we're working on. And I check in every step along the way. So you can go through the tags and see each stream corresponds to a tag, so you can actually see where the code was at that time. Or you just go grab the latest code and just use it. So like here's the pathfinding code. So just jump in and take it. Hopefully my computer will not be slowing down like that. Okay, so anyway, we've got our basic pathfinding, and now let's go dig in a little further. So let's see. Let me get over here. Lost my page. I am going to continue referring to this AI tutorial, so we're going to keep this over here so I can show you what's going on. But okay, where are we? Got our forest map. Oh yeah, we've called this something like A star. There we go, bulb A star. Okay, so here's our little algorithm. So if we go look here, it's kind of similar to this. Maybe I will do this. No, that's not what I wanted. Oop. Nope, still not what I wanted. Here, we're gonna go to a single layout so that I can show you this, and we're gonna get rid of the other things, because right now we're just gonna be messing with this A star algorithm tab. So I want to be able to show you this comparison. So while our frontier, so if you recall, our frontier is kind of the edge, the leading edge that we're looking at. While it's not empty, we are going to get the frontier, and we are going to get the neighbors. We're going to get an element from the frontier, get the neighbors of those elements, and then once we've gotten the neighbors of those elements, we are going to like insert them into our list and extend the frontier, etc., until we get the actual path. Pretty, all this stuff is basically the same stuff. There's a little difference, I think, here where he does the goal, like checks the goal, the early exit when he gets a new element to check. But that means that we have added all of the frontier, and then it's like, oh, we're going to start here, and then it's like, oh, this is the path? All right, exit. But that means that you've added all these other things to the frontier that you didn't actually need to do. So we actually put our check in where we get the neighbor. So if we get a neighbor and all of a sudden that neighbor that we're about to insert is the actual path, well, then we're done, and we don't need to do that. So, and I'm hoping that's correct, and that there's not a bug that I haven't seen. If you do see a bug or anything with that, please let me know. Okay, so now we are going to add, kind of the weight to it for Dijkstra's algorithm. So again, this is it's helpful if you read this ahead of time. I would definitely recommend it. I will actually, you know what? I'm going to put a link in the code so that if you're getting the code later, you can just follow the link and read this. So if you're watching it on YouTube, you can pause now, go to the link, and rejoin me when you've done that. It'll just help you kind of picture things. Okay, so what do we have to do? So the kind of the key to this is that different squares not only have neighbors, etc., they have priority. So when you put elements, you need to have their priority, and then when you add them, you need to evaluate their cost, right? So I made the mistake of not reading this again right before streaming, so I may be a little slow when I'm putting this. But anyway, the priority, track total movements, want the movement cost. Yeah, see, so you might end up visiting locations with different, like the same location over again with a different cost, because you've maybe come from it in one direction and it costs a certain amount, but when you come from another direction, it costs a different amount. So that'll actually alter the logic, as they note. So yeah, here's the key thing. Instead of adding a location to the frontier if the location has never been visited, we'll add it if the new path to the location is better than the previous path. This is really funny. I just realized people are jumping on the stream because I have the title as Let's Play Injustice Gods Among Us, which I am not currently streaming, humorously. That's what I was doing before. So I'm going to update that real quick. As a note, if you do just enjoy the sound of my voice or something, on Thursdays I do a stream of video games. I do like a Let's Play where I play different video games. I try to stick to a lot of indie stuff because I think that a lot of that is more fun and interesting. But I do a lot of different things. So I was doing Injustice Gods Among Us the other day, but I've also done a lot of other games. So, feel free to check that out Thursday mornings if you're interested. Anyway, I just went and edited that. So, anyway, back to this. So, instead of adding a location to the frontier if the location has never been visited, we'll add it if a new path to the location is better than the previous path. First we have a priority queue, which that alters the order in which elements are pulled from it. This is, I believe, Python. So we might just want to take a look at that so we know what our data structure needs to mimic. Now, again, we are not using Python, of course. We're using Lua because that's what Corona uses. So we have to mimic this in Corona, where the different data structures function in different ways. This is not a good page on it. Here we go. Whereas in Lua, it's pared down to very a few kind of universally applicable things, which is part of why Lua script is a very popular scripting language, is that it's very versatile. It can be implemented in a lot of different languages, or on top of a lot of different languages, because it doesn't have a lot of constraints. I'm just wondering if there's anything jumps out to me, something about a priority queue that we want to make sure that we don't miss. Also, it seems that Chrome is having a hard time. That's okay. Priority queue. It's an abstract data type, which is like a queue or stack. Each element has a priority associated with it. Okay, so that's the key. Okay, so what that means is that every time we add something to our list, it's going to have a priority, and when we get something from the list, we actually want the thing with the highest priority. And that's important because that means that our list, currently we just have a list that we just throw stuff on, and we take out like the first one. We have this frontier, and we're just adding these things willy-nilly onto this frontier. What we actually want is a nice priority queue, which let's, for the sake of argument, make a priority queue in Lua and see if somebody has already built like a fancy, nice priority queue. This is something I recommend to any developer, beginner or very experienced. You don't have to write everything yourself, unless you're doing it as a thought exercise and you want to learn about how to build, a priority queue. Or if you're in school, because you'll probably have to do that if you're going to school for programming. But if you're not, it's helpful just to take, pre-built versions that people have. Yeah, see, it's always good to go through the documents. If I didn't read this aloud, but yeah, so we might use this pre-built one. It might be nice and simple, and it's not worth us, because what we care about is implementing this algorithm, this A-star algorithm, which once we build it, anybody should be able to come and grab it and use it. So I would highly recommend, if you don't care about how the AI pathing works, just use the code as is. But if you're trying to program it, this is going to be the process. And so yeah, we want to grab this if we can. But as you notice, like, some people are talking about how this is not an efficient or it's a flawed version. So there's maybe better versions. Try that one. Yes, it's wrong. Follow code is okay. Okay, so here's probably the latest, nicest code. But let's take a look at this and see what we've got here. I'm actually going to copy this into another window because it's going to make it easier. And I can get out of Chrome, which is currently having trouble. And let's go view this as Lua. Cool. And let's go see what this person says. This is Wild Child. Where does that happen? Wild Child, that's probably this chunk here, maybe? Yeah, so let's take a look at that. Now we're gonna go back to two-column layout. And let's take a look at what this person says. So even if you're just grabbing code, it is useful to make sure that that code actually works, that people, the comments, etc., say that it works. And also, sometimes just read through it so that you at least have a base understanding of what you're doing and whether or not, like, it works. And this is a great way to learn a lot of programming, is just to take other people's implemented work and check it out and see if it's good or not. Okay, so what they do is they start with table and they require table. My guess is that this makes this object that they're creating, which they're going to return priority queue. Let's see, where do they use table? Insert, remove, or insert and remove, which they're just using the base table functions. Yeah, so this is their ability to take a table, just a basic table, and get the insert and remove functions from it. Which we can actually, let's go look at that real quick. Insert and remove. So when you have a table in Lua, you have these insert and removes. Now we've been working with tables and doing, because that's the base Lua type. This is, a way to create a table. Let's say this is a table. So, we've been using those all the time, and we've been doing a couple of different types of inserts. So we've been doing, like, here's putting something in an array. And so if, we go ahead and make these numbers, this is like working with an array. We can also do the length of it. This is another way of just kind of thinking of it as an array and just adding elements to the end of the array. We've also been using it as a hash, where we would do something like this, where this is your key that you use, and you use this key to find this element. Those are different ways of doing it, but another way is to do table insert, and this insert and remove elements from arbitrary positions of a list. So the nice thing about insert and remove is that they give you the ability to, look at this as just a simple list. When we're doing it like this, we're actually treating this like a hash, where the key is 0, Whereas if it's just a truly simple list like this, you can actually just insert elements into any given location. So insert is, looks like this is the array, is A is the first element, the location, 1 is the first. Oh yeah, because lists, in Lua, they're 1 based, so that's important to remember. And then this is the element. So you can see here, takes this array that is 10, 20, 30, and it changes it into 15, 10, 20, 30 by inserting this element at space 1. Okay? So anyway, that's insert and remove. Pretty basic. We're going to get rid of those. Okay, so we start priority queue. This is our object. We're going to have this function where we have new, which seems to be, I think new is actually going to create the actual priority queue. Let's see. So, yeah, let me see something real quick. Do they mention usage? Yeah, here you go. So, Euclidean distance. Okay, so this may be not exactly something we want, because this is a priority queue with a specific usage maybe. So this is a distance between two things on a number line. It sounds like, I'm trying to remember math terms. It's a straight line distance between 2 points in Euclidean space. Now, straight line distance between Euclidean space, is Euclidean space 2-dimensional, 3-dimensional? Okay, that is not what we want. That is the distance between 2 points in Euclidean space. We actually just care on a number line. We actually, like, our priority queue does not need to be that complicated. Like this probably gets into all the math. Yeah, it's doing like probably square roots and stuff to figure out the actual length of 3-dimensional, vector between 2 points. That is not what we need. We need just a basic priority queue. These look ugly. I don't like them. Wait. Lua. Here we go. This might be a much nicer version. Let's take a look at this. Put in the usage, and let's take this chunk here. Uses a table with priorities as keys and queues as values. That sounds great. Queues for each priority are created when putting items as needed and are shrunk as necessary when popping items and removed when they are empty. Instead of using a plain array table for each queue, this technique shown in Lua implementation for the queue task is used. Technique shown in the Lua implementation of the queue task. This avoids having table remove to get and remove the first queue element, which is rather slow for big tables. It's good to know. And this is exactly why we look this stuff up, because we could go and write one real quick, but then you get little notes like this that are something that like maybe you didn't know. This avoids using table.remove, which to remove the first element, which is rather slow for big tables. So that's, can be really good to know. And then you go down this rabbit hole of looking at their queue and finding out how that works. This is their priority queue, which, okay, I just want to make sure they're using the code from their queue, like a concept, but they're not actually using the queue itself. Like this priority queue could have just been a wrapper for the queue maybe. So anyway, set meta table. That is not something I am familiar with. So let's go read up on what that is. To make a table act as a meta table. Okay, meta methods. Extension mechanism, which allows you to overload certain operations on Lua objects. Each overload object is a meta table of function meta methods associated with it. These are called when appropriate, similar to the concept of operator overloading from many other languages. Okay, that's cool. As a meta table is a regular Lua table containing a set of meta methods. Certain operators like addition. So like this is where you can do cool things where you like override what happens when you use the plus sign as an addition operator. So you can do really cool things. So anyway, there's really neat things like where you can, I'm trying to think of a good example, but you can make it so that you know, anything happens. So normally, like let's say you have two strings, like 1, and you do this, and you might get something like this. Well, you could, with a meta table, you can overload that, and you can make the result of that be like this. Like maybe it auto inserts a space. Maybe it auto inserts a comma, or maybe it gives you back, you know, this or something. Who knows? Like whatever you want, you can override it and just do whatever you want. So they're setting a meta table of priority queue to priority queue, which I think just makes it so that I think this just makes it so that when our usage is simpler. See, so we have, it makes it so you can use it like this: priority queue, blah blah blah, task, and it goes for each. Ooh, that's interesting. I wonder what this underscore is about. Ooh, and we have string format and unpack. I'm learning all kinds of things about Lua that I haven't used, but are useful. So you're going to put that into that, and then priority task. Oh, this underscore is probably because they're not using it. They don't care what it is. They're just getting these pairs, but they're using, you know, this I pairs just to get the value of task. So you just use underscore to say like, hey, I don't care what this variable is. And here, so it puts them all in, and then priority pops them all out. So we could actually do this real quick and just check this out. It's kind of cool. Let's go into our A-star algorithm. We know this gets called, so let's just drop this in. And let's grab our priority queue, and let's put it in here. This is totally terrible that I would just drop this code in, but could be cool to see. So let's go see what happens. There we go. So as you can see, it put these elements in. The three, I'm sitting here about to point to the screen, which you can't see. Here you go. See, so 3 clear drains, 4 feed cap, 5 make T, 1 solve RC tasks, 2 tax return. That's the order that they come in. So here it is. So cool things. String formats. Unpack this is, so it's taking task, which is a list of elements, and it's unpacking those over this, which it seems like, my guess is that unpack basically separates the elements. Let's find out what put does. Yeah, put. So yeah, here, priority and value. So it's separating them into other method inputs. So this would be the same. This right here is this the equivalent of doing this. Oh, no, that's not right. I mean, this needs to be a 1. And string format is a really common function that you'll see in different languages, where you have a string and then you have these kind of markers that say like, hey, this next parameter that's going to come, put that in that space. What's interesting is it uses %d and %s. My guess is that's to indicate numbers versus strings. Maybe this site does not have it, what I'm looking for. Anyway, my educated guess is, so normally, like, you can put multiple, so let's say it was all strings, it was all just text. You would do something like this, and it would say, all right, this first one is this one, this second one is this one, this third one is not there, and that would cause a problem. But the reason this is a D is because this first one is a number, so that probably might stand for like digit or something, or double as a number. I don't know. That's just a guess, and it's not relevant. But this string format function is a cool thing to use. It makes it really easy instead of doing something where you'd be like, pudding and then plus task 1. Well, actually, in Lua you can't do plus like that. That is a JavaScript thing, as well as other languages. You know, doing something like this or whatever, where you actually have to concatenate all these strings. This gives you this nice simple format. Anyway, so back to what this priority queue is doing. It is taking these elements and putting them on in that same order, and then when you go through the priority to pull them out, hey, look, they come out in the order that you wanted. Now let's do something really interesting and just make this one 4 as well. Save that guy, play, move around, and look at this. So, ooh, interesting. So that broke their priority queue. So this is again why I'd say that you should check for errors. You'll notice that by having 2 elements with the same value, it messed up the ordering of this which I want to double check. We're gonna just put in a few more of these. We're gonna get rid of this because we can actually see the order in which they're getting put in, so we don't even, oh wait, no, not that. We do need them to get put in. So we're gonna see them get put in, and we're going to see what happens if we do this. A real priority queue should not have a problem with this. It should sort numbers that are the same next to each other. So it's like 1, 2, 2, 3, 4, 5, 5, 6, 7, 7, 7, 7, 8 kind of thing. But it looks like they might have a bug. So maybe we will have to explore their code and figure out a bug. 2, 3, no, that worked fine. Let's go back to our previous example. Sometimes there are particular examples. It might have just been how it printed out, and there was something I didn't notice about how it was being printed. No, see, here we go. 3, 2, 4, 4, 5. So that is incorrect. I'm kind of curious, like, so, you know, that this kind of error arises from very particular cases where things are being sorted. So 3 is getting sorted above 2. But in this other case, it was not getting sorted above 2. And so there's certain things where it's like, oh, it might be as simple as like, ooh, that's not what we wanted. As simple as like moving this 2 up here. Because with anything like this, the way it gets sorted is when a new element comes in, it tries to figure out how to sort it. And if there's a bug, Sometimes it just happens to be like what order these things came in. Yeah, see, now it's the correct order. Ooh, that's so fun. Found a bug. Some nicely written code. So let's go take a look at it and see if we can maybe figure out what the bug is. Okay, so we put P and V. This is the priority and the value. We have Q, which is self P. Okay. Interesting. So really it probably comes down to the pop function. So this is just putting it in there. Oh yes, if not Q. Okay, so let's think about this in the terms of an actual value being put in here. So let's say the priority is 1. And I really hope we get to A star by the end of this, but this might be a little bit lagging. So anyway, let's say this is 1. So what we do is we say, hey, let's get self 1. What this does, it says, hey, if that doesn't exist, then let's make a new one. And here we go, first, last. Now that's interesting. I don't know what the purpose is of this having first and last, but we'll find out. And interesting, so the first is 1, the last is 0. That'll be interesting. And so it sets 1, self 1, to this new object right here. Okay, that's all well and good. Now we are going to set last to last plus 1. Okay, so the reason they're doing this is that with their very first one, first and last is 1. There's only one element, okay? Good to know. But they want, if we went and we asked for self 1, and it already exists, meaning there's already an element in it, well, we don't want to do this, but we do still want to increment the last element. So that is why this is 0, so that it can be set to 1 here. So now we have this. Okay, so it definitely exists, and it definitely has first and last. And then what we do is we set. This is fascinating. I'm very curious about this part. We're gonna see how that works. So last plus 1. Okay, so Q dot last. So in this case where we actually just went and put 1, and this thing doesn't exist, so this is what our code looks like. We're gonna put it over here. It's last 1, and now we're gonna go here and add 1. So let's go here and we're gonna add 1 to this example. And then this says Q last is 1. So what that does is it says Q1 equals V, which is our value. Let's say our value is value. And so now what we have is an object that looks like this. First equals 1, last equals 1, and 1 equals value. Okay, so that's great. That's pretty simple. You would screw anything up if you put in first or last. I think that could be a problem. Although that's fascinating. First equals 1. Huh. I wonder if that. Oh, dang it! I don't want to see first element of the table. What I want to do is say first. Now let's get the first addition. Let's see. Let's see if there's something where that is actually a keyword. Because what I'm noticing is that they don't have it wrapped in quotes like this, which could mean something. Maybe we'll figure out later. Okay, anyway, now we're gonna pop. So the key is, what they're doing is they're not worrying about sorting right now. They are just worrying about, sorry, I'm getting rid of all the changes I made. They're just worrying about putting them, all the elements in, and putting them in. So like if you kept adding a bunch of elements, you might end up with something like, oh, interesting, Q1, Q last. Oh yeah, so Q1 is actually going to equal this. This is the value that they're, wait, no, this is not the value. What they've actually done is say Q self P. Ah, here we go, self P equals Q. Okay, so this is what's in self P. So yeah, what we want is self 1 equals like that. Sorry, something just fell. But anyway, self 1 is going to then equal this object that we've created. We've got 1 equals value. Eventually, like, yeah, you're gonna add stuff and you're gonna add, oh, 2, and then that's gonna be 2 equals, you know, value 2. And all of that is still gonna be stored in 1, right? Because that's our priority. And so then if you get other priorities, you might have something like this, like, whoop, right? Where these are, you know, these are the priorities. This is the number of the first element. Here's the number of the last element. And here's the values. So let's go look at what happens when you pop. So for P, Q, so that's priority, 1, 3, 4, 8 type thing. And then Q, which is, this is your Q value. If first is less than or equal to last, then V equals Q first. So the value equals the first. Oh, okay, so first is 1. Okay. Okay, so we put this in at 1. That's fine. So it's going to equal this. That's going to be our value. And then we're going to nil it out. That's great. Then what we're going to do is first equals first plus 1. Oh, so you're going to move first up. Why would you do that? Your whole goal is to just take the first element and get rid of it. So the idea is just that, like, hey, they have this first element, it's here, this is 1. Hey, we added this new one, it's 2. Hey, 1 is less than 2. So that means this is the first element. Pull it out of there. Then increment this to 2. And then get rid of this guy. Okay, I guess. I don't see a real good reason for doing that. And then we're actually going to return the priority and the value. Which is interesting. I don't think that matters that much. And if first is not less than or equal to last, well, so it should be, so that means that it's like this, look. Oh yeah, if it's equal to it, then they're the same, and you're gonna make this null, you're gonna make this 3, and when they go to pop it, you're gonna say, hey, get rid of this nil. Interesting. But that would mean for P, Q. So if we're going through our pairs, this is our priority, 1, 3, 4, 7. So we're still on our first one, 1, right? We have Q. and we pull this element off of Q. We do all this incrementation. What I'm not seeing is that handles this inner thing. Oh, that's what it is. Like I'm trying to see this as a loop, but in our usage, we actually use this down here. We're just popping it continuously until it finishes. Okay, so this is what we're gonna do. This is a great way to test this. Now that we have awesomely found a bug, let's step through it and see how this bug comes about, right? So we're gonna take our code and we are going to step through it. Here, I'm actually gonna move it over here. This is the same priority queue code. Okay, cool. So we're gonna step through this with this in mind. Okay, so when we put it in, we're gonna have self P is 3. So let's go ahead and take one of these as an example. So our very first start one, it's gonna be 3. The value is gonna be clear drains. And this is gonna be 1, and there we go. So that's our first one. That's great. Now we go in, and it's 4. 4 doesn't exist. So first last is 1. 1 equals VCAP. Great. Done it. And we're gonna do the same for 5, which is the same exact code. First last. This could be make T. Sorry, bear with me. I do want this thing to just not be, hey, here's me just implementing something all in my mind. I want it to actually be useful. So I'm talking through everything. So here we go. 4. This is where it gets interesting. So we have priority of 4. We get 4. We're going to get this value right here. This one right here. That's our queue. So we're going to skip this, and we're going to say last plus 1. Okay, so last becomes 2. And then Q last equals V. So that means 2 equals whatever this is. So my instinct is this is not a problem with adding stuff. This really doesn't look like a problem with adding stuff. So now we go and add 2. Great. Now we've got 2. Oh, maybe it is this. That 2 was added down here? That would be fascinating. No, that shouldn't be a problem. So here we go. We put in 2. There we go. And that's what 2 is going to come in. 2. We're going to go 2. It's not there. Blah blah blah. Increment 1. Blah blah. So now let's go look at our pop function. So a cool thing to do would be to do this. Actually, I think I can do this. Go P, Q, or no, actually, let's put Q there. Actually, we're going to put a tab here. So we're going to actually watch this implementation and see what happens. Here we go. We're going to get Q. Let's go look at the Q's value that we're going to. Also, let's put a note of what Q.first was. So we know what Q.first was when we got the value, and then what it is after, because that might be helpful information. And then let's also go like this. We're going to put that just tells us that we set P to nil. Okay, cool. So we got that. This is gonna auto update, maybe. Yes, no? Oh, duh. Of course it's not gonna auto update because this is just our side code. Whoop. Don't know what happened there. So let's take this stuff that I just did and paste it right here into our actual running code. Okay, so now play, click through. Now we get to watch what happens. Okay, so first thing that happens is we go P is 3. And our value is clear drains. Now, okay, so that's interesting. Already, P in pairs, that's not in order. Huh. I wonder if pairs is sorted. I mean, if that's the case, and these pairs are not sorted at any point, like, well, then of course this is going to be wrong. Like, if I go in here and I put 1 here, like, that should also be wrong because they're coming in, they're getting added in a non-sorted fashion. Now this might be annoying to see here, but look, so in this case it did get sorted. So this actually makes me wonder if there's something deeper going wrong. Because the whole point is that this pairs needs to be getting things in order by P, or it just flat out will not work. So that's really fascinating. I have an idea. First, we're going to do this, and we're just not going to return here. And the reason for that is I want to see if this goes in order. Oh, we got to do it over here. If this goes in order, and it doesn't do it. So 3, 2, 4, 5. Why does that happen? It's very odd. We're just gonna experiment with a few of these. Maybe there's something I'm not getting. This needs a comma at the end or it's gonna fail. Let's see. 2, 3, 4, 5. It's totally fine in that case. Even here, this is wrong. Okay, so we're going to try to make this the simplest case that is broken, because that'll help us figure out what's wrong. And maybe it's not even our code, somebody else's. And let's see if we get rid of this. Now look at that. That one is also in the wrong order. 5 is all of a sudden first. Yeah. Huh. So I really don't think pairs is supposed to work like that. I don't think it's sorted. just gonna Lua. Oh, that's really annoying. I just want the Lua description of pairs. You know what? Let's go look and see if we can get the Lua reference here. I wonder if we... Maybe it's in here, tables. Pairs. iPairs, a handy function that allows you to iterate over elements of an array, following the convention that the array ends at its first nil element. Okay, great. Since you can index a table with any value, you can start the indices of an array with any number. It's customary in Lua to start arrays with 1. Okay, problems with equality, that's fine, whatever. You got functions, either, okay. So, I don't have a clear answer for this. This thing assumes that these pairs are in numerical order, which they're not in this case. Like, I don't know if they're even supposed to be. See if we can get sorted keys. If there's a nice like sort. Table.sort. Sees the array is sorted. Okay, so we might have to write our own sort. Table.sort. Yeah, that's annoying. That is not what we want to do. That makes this very heavy. But maybe we need to do that. Right? Is this self? Yeah, we want to sort self. And we want to sort it by priority. Yeah, see, here we go. So, oh, man. Wait a minute. F should be a function. Pairs by keys. Where's this function? Oh, this is weird. We can write an array that traverses a table following the order of its keys. Functional parameter F allows the specification of an alternative order. It first sorts the keys into an array and then iterates on the array. Each step, it returns the key and value from the original table. I just want an example of this function, which they don't have. Okay, whatever. First argument. If this function sort uses the default less than operation corresponding to this. Okay. Alright, we're going to try this out. This function needs to take we have B1 and B2. Alright, we'll just put A and B. And oh wait, yeah, that's not how a function works. Okay, so what we're trying to do here is sort this. This is just a quick and dirty solution. We actually probably want to rewrite this priority queue, make a better one. But for now, I'm just trying to make a quick and dirty solution so I can get to looking at the actual A star stuff. Okay, so these elements, we're gonna go ahead and do this, which is the default, but what I want to do is I just want to see what these are when we do this. Oh man, I keep writing this on the wrong side. Get this, we're gonna copy it, we're gonna put it here, and actually we can just get rid of this. Okay. And I'm gonna get rid of these prints because we don't need them. Just want to look at when I sort it, and it comes out sorted. Okay, so go here. Oh, why did we not see that? We saw nothing. Fascinating. We're not seeing anything. Huh. That sorting breaking everything, maybe? No. That's, oh, I hate this when this scroll gets stuck. Ugh, that's so annoying. Whoops. Okay, so let's go back. Okay, save that. Make sure we're scrolled all the way down so that it updates when we click through. Great, okay, so. Huh, there is no sorting though. It still doesn't happen. And it doesn't affect anything. Huh, let's say we did this. Nope, still doesn't do anything. It's hard to tell if it's even sorting. Self P equals Q. Here's something we can do. See what all the P's in self are before and after sorting. It's gonna fill this with a ton of junk, but we're gonna find out something, maybe, hopefully. Okay, so it goes in, and the P's are all 3, and it's 5, 3. Oh man. I want to see something in between here, so. Okay. Okay, what have we got? So, it's 3, that's fine. And then we sort it, and it's 3. It's 3, 5, and we sort it, it's still 3, 5. Now we're gonna put in 2. And beforehand, 5, 2, 3, and after it's 5, 2, 3. super fascinating as to why this would happen. That is really interesting. Okay, I'm gonna ignore this right now because I'll take a look at it later. This is not maybe critical. So the question is, can we get a simple priority queue? Because that's what we actually need. So the idea is just that when we add something, one of our elements, we're going to give it a priority. We want those to be sorted. So we will figure that out. Let me pause for one moment. Okay, so we've got about an hour, and this priority queue seems like a mess. So what I want to do is figure out if we can get around using it. So let's go take a look at what we need it for. Okay, so when we add elements to our frontier, I'm gonna back this code out so that it's not in the way. Man, so many things that we added here. Because yeah, what matters is that we want a priority queue that we can use to put our elements in. Let's go back here and take a look at what we were working on. So again, we need a priority queue so that things are in order by priority. So when we put this in, it has the start has 0 priority. Whenever you put something new in, we have to get the cost of elements at this point thus far. Then we add it to the cost of the current element, or the cost of moving from the current element to the next element. So that's interesting because theoretically you could have a cost where moving from this side to this side costs something, but moving the other way costs less. I don't know, like maybe climbing uphill costs more than going downhill, something like that. So anyway, this just gets the cost, adds it to the cost so far, gives you a new cost. Now, if the cost so far is less than the cost of the next one, this is a whole thing that they talk about of like, instead of adding it, if it's never been visited, we add it. If it's better than the previous, this is how we determine if it's better than the previous, is we check if the cost so far is, we compare the new cost to the cost so far, and then, get its priority based on that, and add it to the frontier if its priority is such that it's a better path. Now, when I think about that, we need a priority queue, and the key aspect of our priority queue, so let me think. So this one that we grabbed is pretty good, minus the fact that it fails in this one case. So this is a much more complex priority queue, but I wonder if it does something similar that we can then combine the two approaches. So we don't need that. This was us warning about meta tables, sorting, and sort algorithm. We don't need that. Okay. So this is the priority queue. I wonder if anybody's mentioned that this is sort of broken. Blah, blah, blah. Okay. So let's take a look at this. This is probably going to have a similar approach, right? So we have table, insert a value. Oh, interesting. It just immediately inserts a value. This is gonna do a bunch of size stuff, blah, blah, blah. Yeah, we're not gonna be able to use that. Let's do this. See if there are other better versions of it. My guess is that somebody will have a very similar implementation to this one that we were looking at, but that actually works. That's more complex. Okay, so Fibonacci, local declaration. Fibonacci. Why are they using Fibonacci here? Fibonacci heap. That's weird. These are heaps. So this is probably, so the thing is that you have this element of a priority queue has the priorities, which is this portion that you have to keep in order, right? And this 1, 3, blah, blah, blah. But then you also have, hey, here's the elements that are in it, and you have to keep those sorted. You know, it's an interesting thing because, like in our case, like we don't care if these are sorted, so we can actually just, you know, push these into an array and just take the last one. That's totally fine. Like we don't actually care about the order in which they are put in here. We can actually, you know, like remove the first one. Like that's totally fine. What we care about is sorting these. And like, so yeah, so if this uses a heap or whatever data structure, we don't actually care. What we care about is that these get sorted. So if we look at this basic priority queue here that we have here, so let's start with this guy. See if we can make something that works. Okay, so I gotta make it Lua source. Okay. So this, I'm gonna get rid of this. I don't want to waste time keeping track of it. So if it doesn't exist, then make it. And we don't have to get rid of that. That's fine. And all we do is we're gonna say last is Q. Oh yeah, the hashtag of Q. Or yeah, so that gets the length of Q. And then we're gonna add 1, and the value is that. Okay, that's fine. That's like a super simple version. Oh no, I keep trying to auto save. We don't need to save this yet. So, oh yeah, let me grab some of our example code here. We're gonna test this out. Yeah, maybe I should just do this here because I want to make sure that we can go ahead and test it. And let's specifically do the version that doesn't work. I think even just this is good enough. So let me do this. Let's take the original, copy it. We're going to paste that guy here again. I'm not yet going to worry about efficiency of this priority queue. I think that if we really need proficiency, we can go back and look at it. So yeah, so here it's broken. So but that's good. That's our test to tell us if we're doing it right. So let's now take this version that I have here. Paste that guy. Cool. That's our new fancy way. That's different. Okay, so now what happens is we don't actually care about this. All we want to do is say if Q the length of Q is less than or equal to 0. I actually don't even think I want to do that. What I actually want to do is a simpler thing. What we're just going to do is say we're going to do this. We're going to we're about to return. So we're going to go like this. Local v equals q hashtag q. Yeah, let's just take the last element off, right? Actually, you know what? Let's just do table.remove q1. We'll get the first element. The first one in, first one out. That's nice, right? That's the same as we do down here. Our table.remove, right? So we get that first element. That's great. Now, all we're going to do is say if q, so length, is less than or equal to 0, then self, let me look at the code that was there before. Yeah, self p equals nil. Okay, so yeah, if q doesn't exist anymore, like there's nothing in q, then we're going to self p equals nil. Cool. So that's like our basis. Now let's take a look at whether or not it runs. I need to move this window back. I also need to stop sitting away from the mic. Anyway, so we'll hit play and we'll move 5.2. Okay, so it still has the same problem the other one has, of course, that they are not unpacked in priority order. But let's just double check. If we just put in a few others, let's put in 4, 3, or 2, let's go 3. What's interesting is that we're not even, I don't think we're even, oh yeah. So you say putting, oh yeah, so we're not even popping them off. That's because we're not returning the value. Okay. Oop, something's wrong there. Line 59. pq.pop. Prioritize pq.pop. So I don't know what this is here with the comma. Let's find out. Okay. Oh, that's not gonna work. Okay, in pairs. Yeah, Excel list. Okay, that's fine. And we're used to I pairs. That's great. Now, where is this version with in comma? One thing, comma, the other thing. That's what I want to find. It's kind of a hard thing to search because it's a for in. With 2 elements, and I don't get why it has 2 elements. I'm actually just gonna do this. Oh, it gets PQ'd up. Let's just change this. We're gonna go. Let's say value. That's not right. Okay, local value equals PQ dot pop. So what we're gonna do is we're gonna pop it, and then when we're done showing what that is, we're going to update this with another one. And eventually when we pop, it's gonna be nothing because if it never finds it, right? Like if there's no pairs in self, then it's gonna return nil, right? So that'll stop it. And then what we want to do is value. What is value? So at the priority. Oh, okay, yeah. So we returned it like this. Lua has that fancy thing. I actually don't like that. We're gonna go like this. There we go. And that is going to then be like this. Oh, no, yeah. Okay. Now let's try that out. Ah, boo. Okay. Line 23. What do we screw up here? Pair self. Interesting. The first time, bad argument to pairs, table expected got nil. Oh, duh. This needs to be a colon. One of the top 10 things I forget to do in Lua all the time. Okay, we move 61. Okay, so the value we got back. What does it say? Bad argument 3 to format string expected got nil. And before we do this, let's try this. And this, just to see what we've got. Oh, you know what? This is value. This is not right. This should be V. That's probably why. And let's click there. Hey, it printed out a bunch. Well, now it's sorted like it was before. Here's 3, 3, 2, 4, 4, 5. We're gonna get rid of all this because we don't need to see that. Popped is probably good enough. Now we're gonna run it again. Okay, so let's look at popped. Okay, so this is broken just like that previous one was. For some reason, 3s are making it in above 2. So let's figure that out. Let's fix that. So we've just added these elements to here, to self P. Now the interesting thing is pairs. Now what is the difference between pairs and I pairs? We're just looking at this, right? These are the weird Lua specific things that I don't really, I don't know off the top of my head the difference between them. Okay, so I pairs. Iterator is I pairs, which iterates over all elements in an array as illustrated below. Okay, so it gives you the I. Okay, yeah. Why don't we do it as I pairs? No, because it's going to find the first nil value. Yeah, watch. So let's imagine it look like this. This is actually going to stop when it hits the first nil value, which actually might be nothing. Yeah, because there's no, it's looking for 1, and there's no 1. Now let's go look at what pairs does. Pairs function iterates over all elements in a table is similar, except that the iterator function is the next function, which is a primitive function in Lua. Call next, k is the value of table t, returns the next key in the table in an arbitrary order. Yeah, here we go. In an arbitrary order, it's not sorted. Second value returns the first pair. Then there are no more pairs. Next returns nil. Without calling pairs. 3 results, so it gets next. Okay, so interesting. So what I'm trying to think of is a nice way to sort those things. So we just want a basic sort. So I'm wondering if maybe we store the keys, we just sort the keys. That's really ugly. Really want to figure out a nice way to do this. There might not be just a super simple, nice way. So why don't we just do... Okay, so let's get... let's go like this. I think that we just have to iterate through. I want to get the keys, yeah. Key value. Okay, so we're actually gonna do, I know a way that we're gonna do this. Okay, so P is the key and the value. Okay, so what we're gonna do is we're gonna say this. We're gonna go okay, and what we're gonna do is we're gonna go if P is less than the lowest P, then lowest B equals P, right? So we're going to iterate through all of the keys, and we're going to go all right, now we're going to go lowest Q equals Q. Right, so this means just that if we're going to go through all of the pairs, unfortunately we have to go through all of them, so we get all the keys, and if one of those is less than the lowest, whatever our current lowest, then we're going to set the lowest to that. Oh yes, oh yeah, what we want to do is go lowest P or... So what this does is it says like, hey, if lowest P, this basically says if lowest P is nil, actually, you know what? We're gonna go like this, just to be sure. So if it's nil, then we're gonna put the P in the lowest P, and then otherwise we're gonna check if it's less than the lowest, and if it is, then we're gonna put in the lowest, and then we have our lowest Q. Now, what happens is this. Now we've gotten our lowest Q. Now what we do is we are going to say if lowest queue. So this is just to say, hey, we have a lowest queue, right? Because if we don't, then we can just return nil, which is what we do here. If we do, we're going to get the value off of it. If it's less than or equal to 0, we're going to get rid of that, and then we're going to return P and V, and that's fine. Okay, so otherwise, we'll see. Now, okay, so that should work. So yeah, if it's less than the lowest, so this is gonna find us our lowest P and Q, and then this is our normal code that we had. I'm just trying to see if we return nil. Yeah, we want to return nil when it fails. So now let's go look at our test. I think, yeah, that should still work. Okay, so let's go try it out. Oh, it's all broken. All right. 32, remove. Why did remove fail? It failed on the first one. Bag argument to remove. Expected. Ah, here we go. That's the thing. We want our lowest Q. We don't want to use Q anymore because we want to use lowest Q. Also, this needs to be lowest P. There we go. Okay, cool. And let's hit play, and let's walk over here. Hey, 2, 3, 3, 3, 4, 4, 5. Okay, there we go. Hey, we fixed the priority queue implementation. That's awesome. So we're gonna go ahead and include that here as our priority queue. And ours is not too bad. It's not great though. So my theory is that there's better ways to do it out there, but this is one that works. So we're gonna go ahead and take this, drop this priority queue code into this priority queue. There you go. It's great. And then we're going to require it here. And that's great. Okay, so if that all works, my plan will be to, we'll finish. Hopefully we can, ooh. Oh, it's not found. Okay, did I mess up on the names? Priority queue. Yes, I did. I knew that looked weird. Okay, so if this works, then we will move on to the next thing. Okay, yeah, so that worked. Let's move some things around a little bit. Just gonna try this this one more time, and then we're gonna actually make it work with our actual thing, because if it's broken, we should hopefully, no, I know what this is. This is a comma issue, right? Yes. We're just going to use it with our A-star algorithm. Hopefully that will tell us if there's some kind of edge case where this code is broken. But for now, we're going to assume it's correct. Okay, so this is how we get our priority queue. That's great. Let's cut that out because we're going to need it. Delete this. So our frontier, so going back to our code that we're basing this off of. Here we go. Priority queue. So our frontier is a priority queue. Great. So we're going to do the same thing. Here's our nice little priority queue. Save that guy. We're going to have to change a lot about this because priority queue works a little different. Oh, you know what? Before I do any of that, let's put this back to the way it was. Let's get rid of all of this extra code garbage. So what I want to do is I just want to save where our A-star was at before, because it is useful as just a breadth first search. and that will make it so we can use that in the future. Oh man, got to go back a long way. I thought I had actually hit the end of the undo buffer. Okay, yes, based on that, so that's great. And then this is where we start working on this. Okay, so I'm gonna go save as. This is our breadth first search. This might be useful to somebody or us even later as we figure this out. Okay, so now I'm gonna go back to our A star. Oh darn. I was really hoping this would be, oh no, it is. There we go, priority queue. Okay, cool, we're in the same place. Okay, so we're gonna start implementing the priority queue. Okay, so when we put something in there, we need to put a priority. Remember, ours is a little different. This has a, oh, actually, no, it's not. Well, our priority queue has priority first and value second. Yeah, why don't we just change that for the sake of unifying the view with that one. Okay, so that's totally fine. So when we put our starting element in there, here's our start, right? So instead of this is no longer the way we put elements in here. We're going to put start 0, right? Okay, that's simple. And everything else stays mostly the same. Oh, this is interesting. So this break, where we hit the goal, this might be a different, I hope that's not the case, but we'll see. Okay, so the next thing to do is calculate the cost. So we actually need a cost so far, which we don't have. So let's add this. And came from start, none, cost so far, start 0. So when we add our start, we also want to say cost so far is 0. Okay, cool. Cost so far is 0. If the current goal, okay, yeah, so that's our break. Okay, so now we get all the neighbors. Let's move this out here. Okay, so while it's not empty, current blah, 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 we get our neighbors. Okay, so now this is where we want here. This is where we're gonna calculate our cost. Okay, we got about 10 minutes. I wonder if I can bust this out in that much time. Okay, so new cost is the cost so far of current, yep, which is going to be start, right? That's right. And then we add the graph cost. So for us, that's going to be map get cost of current next. Okay, so current next. Okay, so what we're gonna do initially is this is probably something that I don't think we're gonna have time to get to, so I'm just going to implement it in a interim fashion where we're just gonna set the cost to the same for everything. So we're gonna do this. Actually, you know what? We can do a little bit of stuff. So what we're actually getting, I'm trying to remember what our start looks like. Get path. So let's go look at what is it? Builder game. Builder map. No, here. We're gonna have to go find it. I don't remember where we implemented our A star. No breadth first search. Player. Oh yeah, okay, it's in our player. That's right. Okay, let's go find it. Okay, get path from player location. So given a location and a target location, so it's going to be an I and a J. Okay, so get, let's go back here. Let's get our method. It's called get cost. So we're going to get our cost. Okay, so what we want to do, convert display location. We're going to use one of these, a display location to map location. We want this one. It's gonna, well, no, what we want is we want to just look in our map. Based on that, we want to see the tile at that location. So, yeah, we want this guy. It's going to return the forest tile. Okay, so, well, here, for right now, we're going to return 1 or whatever. But what we want is we want to do this, and then we want to get the tile type, and then we want to make a certain tile type where it costs more to move. That's how we're going to test this. But for right now, I just want to make sure that this works. Okay, so if next, so again, I should have done this before. So we're going to copy this guy, move it over here so we can compare, and view it as Python syntax so we can actually read it. There we go. Great. Okay, so what we've got here is our equivalent. So we get our next neighbor, we calculate our cost. The cost looks good. Now here, now normally we would say if it came from, oh man, what is this? Okay, so this is, if it's not a place that it came from, or, oh yeah. So remember, our came from is a multi-dimensional array. So if basically if we're at an element and we say like the element is I is 3 and j is 10, we would say, well, if there's no 3s in our came from, it means there's never been a 3 in I that has come from, then we know it's not in the came from list. And if there is a 3 but there's not a 10, a 310, then we know that it's not in the came from list. But now what we want to change it to is if the cost so far is less than the cost so this thing. So if next is not in cost so far. Okay, so what we're going to do is this. This is why I saved it, because that was useful code that we don't want to lose. Yeah, so wait, this is, I call this next neighbor. Okay, cool. So if next neighbor is, okay, so cost so far. So this means we've never recorded a cost for neighbor. If it's not in that, or it's not that, I'm going to add parentheses because that just makes me feel safer about these things, even though Lua doesn't require them. Or if new cost is less than cost so far of next neighbor. There we go. One thing I'm worried about is that this will trigger even if the cost so far is 0. So we actually need to check how to check if a table contains an element. No, that's not what we want. Check if table has key. No, key, not an element. Maybe it's in lieu of gotchas. Let's see. Values which are false, undeclared variables. Tables are both arrays and dictionaries. Table keys. What I'm trying to find out is simply a nil. Okay, so it's going to return a nil if it's not there. So what we want to say is not equal to nil, because if it's 0, that's fine. We just want to check if it's not nil. Okay, cool. So that's that part. Now we need to do. So now we're gonna add it. Cost so far. Okay. That updates our new cost. Now our priority equals new cost. Okay. I don't know what priority is yet. Priority equals new cost. Okay, I think this is not used anywhere else yet. Okay, and then what we do is frontier. Again, we have to put our neighbor and then the cost, which is our priority. And that's fine. He just put that so that it's a little clearer as to what's happening, that new cost is actually the priority in this priority queue. And then came from next equals current. Yeah, we're already doing that. Okay, cool. Let's save that. Now nothing should have changed really, because we don't have any differences. So first we have to fix whatever just broke, but after that we'll actually have to give spaces different values in order for it to work. So we have parentheses around that, blah blah blah, and I lost the parenthesis at the end here. So it'll be interesting to see if I can manage this. Okay, so could not path to location. Okay, that is a problem. Unfortunately, we're almost out of time, so I'm going to take a little bit of time looking at this, but we may have to continue next week. Unfortunately, the whole figuring out why the priority queue doesn't work took much longer than I thought. I totally even forgot that we needed a priority queue, but that's fine. Let's just see what's going on here. Yeah, so unfortunately we'll have to wait till next week, but then hey, we'll have real A star hopefully then, because we've gotten over the hard parts. At least that's what I'm sincerely hoping. Let's see what's happening here. Well, that's fascinating. Oh, you know what? It's probably, this is wrong. We need self.frontier pop to get the latest. And this, and actually what we do is we got to do that thing that we were doing before, which is so the current equals this pop, while current is not equal to nil. do this, and then at the end, we're gonna go pop. Okay. And what did we break? 119. In the forest map, attempt to perform arithmetic. Forest map, 119. Okay, so we probably got a bad location. Oh, and you know what? That's because when we pop this value, this is not actually what we want as our current. What we want to do is go .v, I think. We're gonna fix that up later because that doesn't look good. That's like actually harder to read. Okay, cool. Now we're on to something. Cost so far, a nil value. Ah, yes, because this should be self.cost so far. Cost so far. All these places where I did not put in self. And let's spell it correctly. Okay, cool. Oh, come on. So close. What are we missing? Attempt to compare a number with nil. Does not equal nil. New cost. What was new cost? Okay, new cost is 1. Self cost so far. Well, so this first one, next neighbor. Oh, you know what? We might not be able to use, we're probably not gonna be able to use objects here in this cost so far. So cost so far, we're probably gonna have to use the same thing that we do with the came from, and make it into an actual, like this, make it into a multi-dimensional array. So that is gonna be the focus of next session. I'm sorry to leave this off on a broken note. I'm not going to check the code in like this. We're just going to do another session before we actually finish this, which I may try to do a special session. But for now, I have to stop streaming, or this will break on YouTube because it'll go over 2 hours. So anyway, hope that you enjoyed learning things about priority queues. You know, like, subscribe, etc. Do all those things, share it, and, you know, go grab the code, use it, make something cool, tell me about it.